Hi, welcome back to Moose and Chemistry. This is going to be our empirical formula lesson number 2. The last lesson we were using grams and then converting it into moles. In this case, we're given percents. So let's see how we work this. One thing you need to remember, and that's very, very important, is that 1% is equal to 1 gram. It's also best to remember that it's important that you have 100% of the sample, which makes the calculations a whole lot easier. So here you have 66% carbon, 5% hydrogen, and 29% oxygen. All right, so now what we need to do is convert that into grams. So 66% is 66 grams. 5% is 5 grams. 29% is 29 grams. And we add that all up, you'll find out that sample totals 100 grams. So that makes things a lot easier. Okay, so now we wanted to convert grams into moles, because remember that when we figure out a chemical compound, it's in the simplest whole number ratio with moles, not grams. So we're going to go 66 grams times 1 mole of carbon divided by 12.01 grams for that one. Here we're going to take 5 grams times 1 mole of hydrogen. It's not going to be diatomic because it's in a compound, 1.01 grams of hydrogen. And this is going to be 29 grams times 1 mole of oxygen, also, which is not going to be diatomic because it's in a compound, 16.00 grams of oxygen. So let's go ahead and figure out what that's going to give us. So 66 divided by 12.01. That's going to give me 5.49 moles of carbon. Okay, 5 divided by 1.01, 5 divided by 1.01 is going to give me 4.95 moles of hydrogen. And then, of course, 29 grams divided by 16.00 grams. It's going to give me 1.81 grams of oxygen. Now what we need to do is we need to look at the smallest number. Which one's the smallest number between 5.49, 4.95, and 1.81? Obviously, it's this one. Okay, so that means we're going to divide every one of these by 1.81, because you're always divided by the smallest number ratio. So 1.81, 1.81, 1.81. So for carbon, let's see, it's going to give me 5.49 divided by 1.81. which is going to give me 3. Okay, 3.0 to be exact. Okay, so 4.95 divided by 1.81 is going to give me 2.7. All right, we'll talk about that in a moment. And we'll put 3.0 just to be good. And this, of course, is going to be 1. Well, this 2.7, it's pretty much close enough to call 3. Okay, it's not like it's 2.5 or 2.4, so we're just going to call it 3. So we're going to approximate that to be 3. So this means the formula is going to be C3H3O. And that's going to give us our chemical compound. Pretty awesome, isn't it? Well, you guys have a snarly day, and we'll see you back here at Moose and Chemistry. What? You don't want to do that? You want another problem? Well, of course. We can do another problem. I was going to let you go and there's just that one. But hey, let's just go ahead and do one more. And then we can have an awesome day. What do you say? All right, let's go ahead and clear these drawings. And we're going to clear that. Okay, and so we're going to write the new one. Okay, so what is the empirical formula of a substance that is made up of 18.7% lithium, 16.3% carbon, and 65% oxygen? Okay, again, we have to remember, very, very important, that 1% is equal to 1 gram. Okay, so also, it's also important, if you add up all these percents, we have approximately 100%, I believe. So let's just double check that to make sure. We got 65 plus 16.3 plus 18.7, and that gives us 100%. So it's important that if you're going to use percent that you have 100% of something. All right, anyway, so now we need to know that we're going to set this up. So we got 18.7 grams of lithium times 1 mole of lithium. If we look on the periodic table, we realize that lithium is 6.94 grams per mole. Okay, and that's going to give us that. It's got 16.3% carbon, so we're going to go 16.3 grams of carbon times 1 mole of carbon, and we know on the periodic table that's 12.01 grams of carbon per mole. And then, of course, oxygen, we have 65 grams of that. So we have 65 grams of oxygen. And again, since it's in a formula, we don't necessarily know that it's not going to be diatomic, so we're going to treat it as it's monatomic. Okay, so it's going to be 1 mole of oxygen divided by 16.00 grams of oxygen. We know that, basically that it's 15.99, but we just round it off to 16 to make things easier. So we cancel out our grams here, just like we're doing here. All right, so we're going to get our calculator here. We're going to take 18.7 divided by 6.94, and that's going to give me, I think, around 2.69. Let me double check. 0.7 divided by 6.94, and that is going to give me 2.69. Okay? It's going to be 2.69 moles of lithium. Okay, so then we're going to take the 16.3 divided by the 12.01, and that's going to give me approximately 1.35 moles of carbon. Not bad so far. Okay, some people might want to argue 1.36 because actually it's 1.357, but we can go with that. 65 divided by 16. It's going to give me 4.06. Yes, 4.06 moles of oxygen. Okay, so which one's the smallest number? Is it the lithium, the carbon, or the oxygen? Obviously, it's the carbon, right? So that means we're going to divide each of these by 1.35. Okay, so we're going to divide that by that, and divide that by that. Okay, so this is going to give me, on the first one, 1.35 divided by 2.69, so we'll go 2.69 divided by 1.35, which is going to give me 1.999, which is basically 2. Okay, 1.35 divided by 1.35 is 1. Okay, and then we get that 4.06 divided by 1.35, and that's going to give me 3.00. All right, so now our formula is going to be Li2CO3. Okay, the 2 is that 2 right there. This 1 is said to be 1 there. And that 3 is that 3 there. So again, it's lithium carbonate is the name of the compound. Now you guys have a snarly day. And we'll see you back here at Moose and Chemistry. All right.